Hi, welcome to today's lesson on volume of prisms and cylinders. If you've been following along, we've been talking about surface area of prisms and cylinders, and now we're going to look at volume. And usually volume is actually easier. So it always seems strange to me that we don't start with volume, we start with surface area. It's kind of the easier side of things, and then we go with the hard thing, and then we go back to the easier. If you refer back to the previous video, you'll see that I gave you a step-by-step guide, and we're going to follow that same step-by-step guide, except we're actually going to remove one of the steps. So we're actually going to make it easier because everything else is going to be the same regardless. So let's start with prism. And if we look at ourselves, we get ourselves a nice little prism here. And we'll start with the easiest of prisms, the rectangular prism. This is probably the most common, without a doubt. I mean, every box you see, no matter what its dimensions are, is a rectangular prism. And wanting to know the volume is very important. If you think about all the things that are shipped and all the packaging peanuts you get in it and all the, why do they inflate balloons of air, you know, it's always interesting to see how shipping companies or companies that ship a lot of products like Amazon or FedEx or those kind of places, how they utilize the space within the box that they're working with. Now, obviously, they're not going to design a new box every time they want to ship a different product, so they have to. That's where they have to kind of manipulate. Well, this is the box. This is the box that's closest to shipping the thing that we want. So, how do we fill up the rest of the space so it's not rattling around in there and maybe gets broken? Okay, so there's a lot of logistics to packaging, and that's where this comes in. So let's give ourselves some measurements. We'll make this one. Let's make this 10 inches, we're going to make this one, oh, we'll just make it easy on myself. We'll make this one 8 inches, we'll make this one 6 inches. Okay, and if we could, let's see if we can sort of give it a three-dimensional feel. There we go. Now you really see it as a box, 3D, where the, you know, those are the different sides. Now, because it's a rectangular prism, we know that the base is a rectangle. That's, again, goes back to that naming convention. Why do we call it this? Why do we call it a that? Well, I still want to stick with that, and I want to make sure we're very keen on step one when doing these is to name the shape. And when we name the shape, we've told ourselves something about the base and what it is, and that sends us down the road of how do we find its area and so on. So we're going to, you know, steps there, but we'll add to them here. So we're going to call this is a rectangular prism. And both of those things actually tell us something. So the rectangular part tells us the base is a rectangle, and the prism part tells us it's a 3D object where the other sides are also rectangles. That's what a prism is. Okay, so a lot of information is right there just in the name, which is why we spend that second. When you're doing it on your own, you probably just say it. You know, you don't have to write it down. You just go, oh, that's a rectangular prism. I know that means that the base is a rectangle. So we're going to do that. We're going to redraw the base. And again, we're using that capital B because we're going to be finding its area. We're going to do it with the measurements. Now, the nice thing here is because this is a rectangular prism, that means that the base is a rectangle, and because it's a prism, it means that all the other sides are rectangles. So we can do this with any values. We can call anything we want the base. So in fact, I might even just do this twice just to show you that it doesn't even matter which one you call the base, which one you call, on a rectangular prism at least. And a lot of people, I know in elementary school you learned, oh, you're just like, oh, it's length times width times height. We're great. It's like, yeah. Unfortunately, people keep trying to apply that to every single prism, and it doesn't. This will work for every prism and every cylinder, and that's why I want to use it. Okay, you know, elementary school they give you the easiest shape they can. I'm going to give you every shape. Okay, so we're going to draw the base. I can call anything I want the base. I could say this front piece that would be 10 by 6. I could say this side piece that's 8 by 6. I could say the bottom here that's 10 by 8. Whatever works, doesn't matter. I'm going to use the front here. I'll do this 10 by 6. So I'm going to draw my prism. The other nice thing about what I'm doing here is that when I do decide, okay, well, this one's 10 inches and this is 6 inches, I know what my other value is that I haven't used here is the 8, and I know that's going to be my height of my prism for down the road here. And not very far down the road, a couple of questions later. Step 3 is we're going to find the area of the base. Now, that's going to change from shape to shape. If my base were a triangle, that's one formula. If my base is a rectangle, that's one formula. If my base is a cylinder and my base is a circle, that's a different formula. So this is where you actually have to make some decision about, well, how do I do that? How do I find the area of the base? What is the formula for that shape? Is it a triangle? Is it a trapezoid? Is it a circle? Is it a rectangle? What is that shape? And how do I find its area? Well, fortunately for me, rectangles are simply length times width. So 10 inches times 6 inches, and that's going to be 60 inches squared or 60 square inches. Again, depending on how you like to say it, depending on your preference. They mean the same thing. Square inches, inches squared mean the same thing. Now, right here, if we were finding surface area, the next thing we'd need is the perimeter of the base, but we're not. We're not finding the perimeter of the base. We get to skip that. That's the step we no longer need, is step 4, the perimeter of the base. If we were also asked to find its surface area, then we would. And it's always nice to see those two things side by side, be able to do both. Find an area, find a surface area, especially if you're into building, okay? How much space do you get inside for how much building material do you get outside? It's a very common problem in construction. It's one of the reasons why most buildings are square or as close to square as they can be, because those are the most efficient uses of space. You get the most inside for the least building material. But we're going to skip it because we don't need it. So step 4 for us is going to be identify. And again, this means we're not actually calculating anything. Identify the height of the prism. And again, that's always going to be the number I haven't used yet. In our case, it's going to be the 8. So that's going to be H is going to be 8 inches. Nice and easy. I don't have to do much calculation. And then the last step here is going to be to find the volume. And that has one formula for all prisms and all cylinders. One formula. Volume equals the base's area times the height. Doesn't even matter what the base's area was, doesn't matter what the shape of the base was. Once we found its area here, we're going to multiply this times this. That's it. 60 times 8. So volume, whoops, yeah, well, getting ahead of myself there. So volume equals 60 inches squared times 8 inches. Move those over, knock some things on the floor. Our volume is going to be 480 inches cubed, because we have 1, 2, 3. We have the word inches 3 times. In fact, anything volume is always going to be to the 3rd power. Okay, it's always what they call cubic units, which is to say, if you had a cube, meaning like the die that I showed you in previous videos, it's right over there, I can grab it. It's 3-dimensional, 3. If we're finding its volume, 3. Surface area is always 2, volume is always 3. It doesn't matter what the shape is. Cylinder, circle, whatever, it doesn't matter. Cylinder, prism, weird shape. Its volume is always measured in cubic units. And I like this because it's very straightforward. Again, a step by step. And you're going to get to that point where you can go, well, I don't need to go. I can name the shape without writing it down. I can just look at it and go, that's a blank. That's a rectangular prism. Redrawing the base, I think that's very helpful because it really helps you isolate the numbers that are relevant to your question. It also helps you with this one later because you've kind of omitted it, you've left it out, and when you go looking for it, it's the only one you haven't been using. Now, there are times when you're going to get numbers that you don't need. That's one of the things you always have to be careful of, because people give you the information. They don't know necessarily what you want to do with it. You know, do you want to paint the inside of the room, or are you interested in how much storage you can put in it, like a storage locker? Well, maybe you want to do both. So now you need 2 different sets of information. One to find its surface area for painting purposes, and one to find its volume for storage purposes. So they may go, here's all the information, and you just have to be able to piece out what you need. And that's why I like these step-by-step instructions. And again, I like this because this works every time for every single prism, every single cylinder. Okay, let me give you a quick show and tell thing of just what we're dealing with. Okay, so we have a CD here, okay, a little rectangle, okay, but I'm sitting on it. All we want now for volume is, if I keep putting ones on top, just until I get to the top of my stack, how many did I stack up? And that's where this is. I have this thing on the bottom here, and then I just stack it up. Or the way I did it, I stacked them that way, like I was putting them into a storage position. So I'm storing them this way. Okay, so that's what you're always looking for, and that's why this base area times height works every single time, regardless of whether it's a cylinder or a prism or a whatever, trapezoidal prism. Really, those are the only two things we're looking at. Prisms of all different makes and models, trapezoidal, rectangular, triangular, hexagonal, you name it, and cylinders. And the formula here does not change, because what will change here is when we go to find the area. This is the only thing that's going to change, is step 3. When you have to find the area of the base, well, what is the base? That's going to have different formulas. Is the base a rectangle? Is the base a triangle? Is the base a circle? That is where you will make the only decisions. Okay? So let me give you one more example of this. And the other thing is, we are going to see, the next video I'm going to make is going to be on volume of cones and pyramids. And this step-by-step isn't going to change very much. In fact, the only thing that's going to change is this formula down here at the bottom, and only by a tiny little change. And we'll see that in just, we might even see that in this video. I might only make one video, I don't know. But let's go ahead and erase all of this. I'm going to keep this step by step. And now we're going to do a cylinder. Okay, not great. I think I'll even make it a little challenging. We'll give us this number as, let's go 12 centimeters, and then we'll make this one 20 centimeters. Make it, we'll at least make the numbers relatively easy for me. So again, I'm not changing a single thing over here. I'm doing everything exactly the same. The only thing that really is going to change is when I go to find the area of the base, I'm not going to use length times width, because it's not a rectangle, it's a circle. Because I named the shape, that's a cylinder. And a cylinder obviously means the base is a circle. Circle, cylinder, kind of go together that way. When I go to redraw the base, I draw myself a circle. I'm given that this is 12 centimeters. Now I'm going to go find the area of the base. This is where I actually have to do some calculations, and I have to know a little bit. I have to know some of the formulas, I have to know some of the variations, and so on and so forth. Okay, the difference between finding the area of a rectangle versus a triangle versus a trapezoid versus, in this case, a circle. Well, area of a circle is pi times the radius squared. Well, I don't have the radius. That's the first thing I notice. Okay, so this is a perfect example of, you may not even be given the information that you really want. You got information that you can use to get the information you want, but they didn't give me what I wanted. They gave me the diameter, the whole distance across, instead of the radius. So I have to take a moment and go, diameter divided by 2 is my radius, so 12 centimeters divided by 2, which is 6 centimeters, that's my radius. Okay, now I can find my area. So still sticking with this, so area equals pi times 6 centimeters, and we're going to square that. 6 squared is 36, and we're going to keep the pi. And I keep stressing on this point. Pi should be part of your answer, and you should keep it the whole time. Do not waste time multiplying by 3.14. You will find that that is most of the time unnecessary for anything until it is. And what I mean by that is, if you're taking a test, maybe they tell you to use 3.14, still wait till the end. Wait till the very, very, very end. If you're actually doing something where you had to actually get the exact measurements, still wait till the end. I'm not going to multiply by pi just yet. 4, I'm going to identify the height. Well, it's real easy with a cylinder because it's the distance from one circle to the other circle, and that's this distance right here. That's the 20 centimeters. And again, it's that number I didn't use yet. I used the 12, but I didn't use the 20. That's the other nice thing about cylinders. You only get a couple of numbers because you don't need very many. You got to be careful if they give you an oblique one. Sometimes they'll give you a thing called slant height, which we aren't using for anything yet. And then we're using that same volume formula. Volume equals 36 pi centimeters squared times 20 centimeters. 36 times 2 is 72. Add a 0, so 720. And then we got to keep that pi centimeters cubed. Again, so cubic units. Even though the shape is round, it's still called cubic units. Now, if I had to, absolutely had to multiply by 3.14, this is where I would do it. So if I were, if this were like a grain silo, for example, and I was trying to come up with the how much it can store, or how much volume is in a Pringles can, for example, then I would actually go ahead and multiply by 3.14 at this point. Until then, I'm not wasting my time, because if I do it here, then instead of getting a nice easy 36 times 20, I'd have 36 times 3.14. So now I got a 112.36 that I got to then multiply. Wait till the end. Wait till the very last step of the problem, and only if you need it. Because the truth is, this is the right answer. This answer is not only correct, but exact. It is precise. As soon as I multiply by 3.14, or I even hit the number on my calculator for pi that gives me this crazy long decimal, I've still rounded it off, because pi is a never-ending decimal. So as soon as you give it an end, you're losing everything that came after it that would have been slightly more accurate, because you could always add one more digit and make it that much more accurate. Right now, that's not it. So you want to keep that as part of your answer. And you'll find you'll do a lot of measurements later on with calculations where you'll just leave pi the whole time. You'll never take it out. All the way up to the highest math classes. Okay. In fact, I find that the higher you get, the less you actually waste time multiplying by pi, because most people are understanding that, hey, I'm going to hit a button on my calculator and that's going to give me pi, and then I'm going to say okay, and that's going to be, if I had to know for actual storage purposes, like I said, I'm the guy designing the new Pringles can and I want to know how much storage it actually has, then I'm actually going to need to multiply by something, and I'm going to want to multiply it out all the way to give me the most exact answer I can. So I wouldn't even use 3.14. I would hit the button and go all the way to the end of the calculator, or at the bare minimum go 3.14159, go out 5 digits and give myself I'm pretty darn close to knowing exactly where I am. Okay? So these 5 steps work for, again, every prism, every cylinder. Okay? And if you remember back to the previous video on surface area, the only thing that changed was we had a step in here about finding the perimeter of the base, which we no longer need, because we're not worried about the inside, we're not worried about the outside of the shape, we're only worried about the inside of the shape. And again, think of it like a whole bunch of circles, a whole bunch of discs lined up. We just want to know how much volume that takes up. That could be because we're shipping them, that could be because we want to ship something in them, depending on what your reasoning is. But there's a lot of applications, surprisingly large numbers of applications for finding volume of prisms and cylinders, okay, because of, especially in light of recent events, so much shipping. So many things get transported. It's important to know how much space is in the truck, how much space is in the box, how big is the item, how much space is in the item, how do you fill the space that isn't utilized. We don't have an infinite number of boxes, so we have to use the ones we have, and sometimes we need to make sure there's, like I said, a buffer in there so they're not getting broken. So you may find this to be something you use more than you think. Okay. But the nice thing here is that this step-by-step works every time, regardless of what the shape is. And the only thing that changes is this step 3. How do we find the area of the base? What is the base? That's going to determine how we find its area. Everything else is the same, including the volume formula. Because it doesn't matter if we're stacking up rectangular CDs or the CDs themselves, which are circular, or who knows what. Same formula. So this doesn't change, this doesn't change. Just how to do this changes. And then the rest is all, again, the same. All right? And that would be volume of prisms and cylinders. Next up will be cones and pyramids. Probably going to be pretty short because there's not much I'm going to have to change from this step-by-step guide. In fact, I may even leave it up there and just modify it ever so slightly. All right, I look forward to seeing you.